Okay, so for this video, I'm gonna introduce some of the most important functions in Ansys so that you can know where those functions are when you want to use it. Uh, First, let's say we have a CAD file, then we want to use it as our geometry. Then we should go to this geometry. We right click on it. Then we can see import there's a import geometry uh, option. Then you can browse your computer and find the location where your file is. Then you just import the file. But make sure to set your CAD file into a proper format so that Ansys can read your file. Yeah, that's the file import. For the format requirements, you can just Google. It's everywhere online. Then, okay, maybe let's go to design modeler. Okay, so this is the UI for design modeler. It's a little bit messy and complicated, but let's say if you want to sketch something or like create the model by ourselves, then this could be the main tool we are using. So first you can see on the left we have different planes. Then we right click on it, we can look at the plane. Then you go to your bottom right corner, can resume the original angle view. Then okay, let's say we want to sketch something on XY plane. So we look at the plane first. Then you go here, you see there's a modeling, then there's a sketching. We click on sketching. Then we see the first option is draw. So we have all kinds of drawing tools to use. Yeah, so if you want to draw anything, you just find the thing here. Quite similar to SolidWorks and all those CADing software. Then we have modify. Modify mainly is like it's also like SolidWorks where you can modify your sketching or those like filler, chamfer or those. Yeah, but if let's say if we have a 2D sketch, right, then the main tool we are going to use is probably trim. The rest, to be honest, I don't actually use it very often. Yeah, because most of the time still we are importing the geometry, so the geometry should be still there. For the simple models, we might sketch the thing out, so shouldn't be a problem here. Also, these, I think there can be tutorials online, so that we can just learn how to use it, or we just explore ourselves. Yeah, then we have dimensions. So okay, so let's say we have a triangle. Yeah, it's simple. Let's say we have a rectangle here. Then for dimensions, normally we just use a general. It's similar to the SolidWorks Smart Dimensions. So let's say we select this already. So we click on this, then we see we have this H1 here. Then you go to your bottom left corner, you see dimensions. The first one is H1, then it's 25 meters long. Yeah, so then you can, but one thing is, it's a bit different from SolidWorks because you adjust your dimensions here, not like you click on it, then you can just type in the dimensions. And also, I think, let's say if I have a line here. Okay, yeah, so now you can see if you use the angle tool for this, then you can adjust the angle. Let's say we have it as 120. Yeah, then the line shifted to here. Okay, the rest I think is most of the time general should be enough for adjusting dimensions. Sometimes you may need to use angle and all this. You can explore it yourself. Then for constraint, uh, I don't really use it to be honest. It's quite similar to SolidWorks, so yeah, probably if you know SolidWorks, you can use it quite easily. Yeah, then settings is no, I don't use it. I also don't know what they are for. Yeah, so these are main the main tools for sketching. Then after let's say yours, okay, let's complete the shape. Okay, then I want to trim off the line in the middle. Yeah, okay. So now let's go back to modeling. So now you can see under the XY plane tree you have one, what is it called? You have one object down there saying sketch one. So this is your sketch. You can see on the right it's highlighted. Then but this is not enough for modeling because you need to go. Currently it's still only a sketch, so it's just line. It's just lines. So if you on the surface, you need to go to concept. Then you can see here there's surfaces from sketches. Yeah, then you click on the sketch one option to select it. Then you click on surfaces from sketches. Okay, now you can see on your bottom left, the base object is the one that's been highlighted. So you click on apply. Then the rest, I don't think we need to change it. The thickness, I think it's for it's probably like thin surface, then it still has a thickness. That's why they put the thickness there. Most of the time this is done, so you can see the lightening mark here. Then you see here, right? You have a generate. So click on generate. Okay, now you can see it's a whole surface, but it probably is just a plain surface with no thickness. Yeah. Okay, so now this is our surface. Also for this one, let's say you do some random thing to your model. Let's say you accidentally move it here. Then you only back in to the middle area. Then you go here. You see right, there's a zoom to fit. You click on it. Okay, now it's the normal position. Let's say you want the standard. Uh, is it 45 angle? 45 degrees of angle view, and probably then you just do it again. Now you can see it's right in the middle. Yeah, okay, so that's it for let me see. Yeah, probably those are the most basic functions in this design modeler software. Yeah, also remember always adjust your unit. So let's say you want all the things in inches. You remember before you do your modeling here, you go to your units, you select inch, then you can do everything. Because if you have started to do your model, then you suddenly realize, oh, I got my measurement, I got my units wrong. Then it will be suddenly be very big or very small. Yeah, then that's very inconvenient. Okay, now go let's go to Ansys Mechanical to see all the functions. So for Ansys Mechanical, in this static structural with this static structural tool, you can double click on any of these to get access to it. But before that, let's say we have a model. In this case, I'm using the airfoil file for demonstration. So you can see, yeah, it was geometry. So you see there's a analysis type here. So if you're dealing with a 2D structure, you remember to switch this thing to 2D. In this case, it's an airfoil, so it's still 3D. So yeah. Okay, so here are all the things. Okay, so if you see green ticks here, right, it means the the data is updated. If you see some other marks, probably means you need to right click on the first one with a different mark, and you see there's a update here. So you click on this, then probably it will change to the green tick. Because sometimes when there's a different mark, it's because let's say you have this flow here, then you somehow change the geometry in the original file. Then all these will become a different will have a different marker because the original file was changed. So these are all based on the old file. Now you have a new file. Now you have a new geometry. Then the rest you also need to update them. Yeah, if you have a great change to the geometry, then I suggest you just redo the whole process. Let's say you build up the flow already, but then you suddenly want to change the source of your flow. You might not be able to do it with the algorithm of Ansys. Yeah, just how Ansys is. Okay, so then we double click on model to open Ansys Mechanical. Okay, so there is our airfoil here. So for Ansys Mechanical, we have a lot of functions to use. I would say the ones we use the most often is first geometry. So geometry is mainly as you can see here, the material assignment and the thickness here. Yeah, mainly these two, because the rest is all by default, I would suggest. Most of the time we don't really change them like these properties, no. Okay, then for this model term we have a insert here. So now here we can insert remote point, symmetry, all these if it's only one whole shape like this, like an airfoil, you don't really need to use these, I would say. But sometimes let's say you have uh, a chassis or all those, they can be helpful. Yeah, also for this same as design modeler, you can just Google if you don't know what a function does or how to use a function. There should be videos about them. Okay, then let's go to coordinate. So coordinate system, that most of the time, let's say if you only have a simple model, cantilever beam models, you can just use the default global coordinate system. But let's say you have a ring shape, you have a barrel, you have a pressure vessel, then in that case you need your circumferential direction, you need your radius orientation. Then this global coordinate system won't be enough for that. So if you are if you need another system, you can right click on coordinate system, then you can go to insert and go to insert a new coordinate system. So now this is details of the new coordinate system. So here for the type, you can change it from Cartesian to cylindrical. So let's say pressure vessel or like barrel ring shape, you can use the cylindrical. Or sometimes even for our own convenience, let's say you want another origin for a certain part, then you can build another Cartesian and locate the origin at the position you want. Then you can do it. Yeah, so the rest for the top, the definition part, we don't need to care about it. Then this guy is for the position of origin. So you can use your geometry selection. Let's say I have a vertex selection. Then I click on this point. You see now I can apply. Yeah, now this new coordinate system is here. Okay, let's now do this. Also, you can use your global coordinate to locate your new coordinate system. So let's say we want the two origins to overlap. So we just type in all 0. Now you see this is overlapping with the old global coordinate system. Yeah, so these are two ways to use to define this origin position. Okay, then the rest we don't really need to care about it because it's all by default, I suppose, most of the time. Okay, then let's go to mesh. Okay, mesh is, I would say, one of the most important function in this Ansys Mechanical because with a good mesh you can get a good result. If you don't mesh your model well, you will not get the best result you can get. Yeah, that's just how important this meshing is. So for this one in the new user interface, you can go to, you see your top left, you have a mesh option here. You click on it, you can see all these functions under the mesh function. So sizing is a basic function for meshing. So this sizing is very simple. You just, what it says is controlling the size for the elements. So you can see by default it has a size, but you can always change it here. Then geometry, this one is for the selection. Let's say I want, okay, let's say I want the, okay, okay, it's two surfaces. Okay, let's say I want the top surface to be selected. So I use, yeah, you can go here, you see, right? These are all the selection tools. And here you have the body selection, face selection, and edge selection. And the one I just used, vertex selection. So in this case, if I want to do the the mesh sizing to the surface, I choose this face selection. Then I click on this. Okay. Also at the same time, you can see on the at the corner here, you have two surfaces lying here. So let me adjust it to an angle where you can see the difference. Okay, now you can see the green part is the one that I selected. So now you can see the top surface was selected, and this surface at the front is highlighted in red. But then if I switch to the surface at the back, then you can see this bottom surface is selected. So this tool is for you to locate the surface or object or part you want to select, because sometimes the parts are overlapping, and the one you want might not always be at the front. So then you can use this function here to swap the surface. Yeah, swap the surface to the one you want. Now let's say I want the top surface, then I choose the one at the front. Then I hit apply. Yeah, then okay, now you can see it's here, but I don't want to mess up the file, so I'll just delete it. Okay, also this, you can see there's a circle around my cursor. This is mesh sizing. So if you have a bigger sizing somewhere, then the size of the circle will change with the size of your elements. Okay, so okay, I just saw you see right, because I changed something. Sometimes it can be this lightning mark here instead of the green tick in here. So now you can see it's all like this. This means you change your geometry or your model, but you haven't updated yet. That's why here I'm gonna hit the update button here. Okay, it's processing. Okay, now you can see, because this one is only for mesh, so it's only updating the mesh part. For the whole thing, you need to hit the solve button to solve the whole thing and convert all these marks into the green tick. Okay, so for this freeze mesh, I remember I found a website explaining what this is. So these are converting your small elements into a bigger region, so that for the calculation it will be so that on calculation wise it will be easier for the computer to get the result. Also, you can get the result faster. Okay, that's okay. This okay refinement. Okay, so refinement is more or less like a. Let's say you have this. Okay, let's change to the edge selection tool first. Let's say you have these two edges. So most of the time, the force conditions around the sharp corners are quite different from the flat surface because it's at the very end of the whole surface and like the edges, so the force can be complicated. Okay, now as you can see, just now it wasn't like this. Okay, I didn't do the refinement for the other side. So first we can see on this side it's quite messy and dense here. The other side I didn't do anything to it. So okay, now I can see this side is relatively tidy and clean. Yeah. Oh yeah. So in this case, meshing is probably let's say you have sharp corners and edges, then your normal element sizing it might be too big for the sharp angles. That's why they use this refinement to make your element sizing smaller. Then as you can see here, the sizing is definitely smaller than this. Then smaller sizing for sharp corners is probably easier to calculate the force and all those. Okay, so basically that's what we do for meshing. Yeah, most of the time it's mainly sizing and face meshing. Okay, so for the physics setup, let's use this metal sheet as an example. So as you can see, when you click on static structure, there's an environment option here. You click on it, you can see your loads support. So um, oh, this is okay. So you right click on it, you can see you can insert all these things. So for the normally we will use force or pressure. So for the force, you can apply it on a vertex, or you can apply it on an edge, or you can just apply it on the whole surface. Yeah, so when you apply it on a vertex, it can be a point force. Yeah, that's what I think. So now let's just apply it on the left side of the metal sheet. Okay, it's in pound. Let's say 100. Or with the directions. Yeah, remember the direction. Oh yeah, we apply your whatever it is force, pressures. You have this orientation definition. So you can define it by a vector or you can define it by components. So when you swap it to components, you can see you have your x, y, z components. Now let's say I want the force to be in x direction. So then I put this one. Then I want it to be in tension. Then I put negative 100. Okay, now you can see the arrow here. It's pointing out of the edge. Okay, then the force is done. Okay, then let's look at the support side. So for the support, we have all these support. But most of the time we will use, okay, actually for this support, right, you have, we will move your cursor onto the name. You can see a brief explanation on what it does. So I think I won't really explain every one of them since most of the time I only use fixed support or frictionless support. For the rest, they are definitely useful. It just for simple force reaction model, maybe we cannot use them. Yeah, so it's mainly pressure, force, fixed support, and frictionless support that I was using the whole time. Okay, let's add one support on the, let's say the right side. Okay, let's add fixed support. So you remember to always make sure your selection tool is correct. Now I'm selecting the edge, so I'm using the edge selection tool. Okay, click on the right side. Key apply. Okay, now this is done. Okay, so before you solve the whole thing, actually now you can solve the whole thing. You can already solve the whole thing, but sometimes you can also put your final analysis here. Okay, so now let's introduce the final analysis. So up here you have your deformation, you have your strain, you have your stress. So mainly for what we are learning mechanics of structure, mainly is deformation, strain, and stress. And for deformation, they have total deformation, which means they will analyze the deformation for the whole body. Then directional is simple. They will analyze the deformation in the direction you assign. Yeah, so you can see the orientation of the deformation y, x, z. Yeah, directional. Also, you can, let's say you have a different part on this metal sheet, then you can select the different part, then you analyze it. So now we only have the whole thing, so we'll just analyze all bodies. Then let's now do this. Okay, I actually can just put one total deformation here. So for this one, you don't need to change anything because it's all by default. Yeah, then this one is here. Let's put a normal string, I guess. Okay, let's put a normal string on the surface here. Okay, in x direction, so that we can see what the tension does to the surface. Okay, most of the time we only need to pay attention to this geometry selection and this orientation selection. Make sure you make them correct so that you can get the result you want. Okay, the stress is also helpful, but in this case I don't think we will use it. So yeah, as he says, it will just give you the stress in a given direction. Yeah, also for shear stress. Okay, so now we have our physics setup, we have our analysis tool here. Now we can hit the solve button. Oh wait, I forgot. Oh yeah, I forgot to assign. Yeah, actually, yeah, this is a problem you may face in the future because sometimes, let's say you are modeling a metal sheet. It has a thickness, so if it is a 3D model, it has a thickness. So you cannot just leave the thickness, put it aside, and don't care about it. So you should always remember. It's in inches, so you should always remember to put a thickness there. Okay, assignment. It's just a random model, so I don't need to care about it. Okay, now let's hit solve. Okay, when you see all green ticks means the work is done. Okay, now you can see the deformations. Also here, right, under the graph, you have the animation. So if you hit play, you can see it's stretching to the left because the tension is towards the left. Yeah, the right side is not moving because we have the fixed support there. Also, we can check on strain here. So as you can see, as we pull it away from the right side, the corners and all those have the most strain. Okay, also for this deformation thing, actually they have the scaling tool here. So what we are looking at now is actually an over exaggerated version of the deformation. So if you want the real deformation, you can go here. Then you select the true scale. Then you can see actually if you are using our eyes, we cannot really tell the deformation because it's structural steel also is very stiff. So the deformation is actually very small. Okay, I think that's it for the basic function introduction.